we can project an outline of the object on the paper. We will use orthographic projection where lines of sight are parallel to each other. These lines emerge from the corner points of the object and strike the projection plane. The image formed on the projection plane is known as the projection. The lines of sight are also known as the projectors. The size and the shape of the projection depends on the angle at which the object is being viewed and the distance between the object and the viewer. The projectors are perpendicular to the plane of projection. This type is known as orthogonal projection, which is prominently used in engineering drawing as they show true size proportions and shape of the objects. Planes of projection are mutually perpendicular planes known as principal or reference planes. One of them is the vertical plane VP and other one is horizontal plane HP. The intersecting line XY is the reference line. These intersecting planes create four quadrants named as first, second, third and fourth in anti-clockwise direction. There is one more plane known as auxiliary vertical plane AVP or profile plane PP. We use AVP when the view is from the left side or the right side of the object. Alright, now consider the object in the first quadrant. Looking at it from the front side, the image is formed on the VP and is known as front view or elevation. And if we look at it from the top, then the image formed on the HP is known as top view or plan. As the object is in the first quadrant, the projection obtained is the first angle projection. Similarly, if object is situated in the third quadrant, then projection is known as third angle projection. In the first angle projection, the object lies above HP and in front of VP. The projection of the object is like a mirror image. For the third angle projection, the object lies below the HP and behind VP, and plane of projection is assumed to be transparent, lies between the observer and the object. So the line of sight passes through the plane, thus forming an image of the object. So with these fundamentals of projection, we are ready to delve deeper into engineering drawing.
In the previous lecture, I've explained the problem related to the projections of the solids, in which I've taken a pentagonal pyramid and it's one of its triangular faces is actually resting on the horizontal plane. So I've taken the initial positions and final positions, and after that, when these pentagonal pyramids triangular faces is resting on the horizontal plane, I have taken the front view and the top view as well. So after that, we have inclined the axis of this pentagonal pyramid at 19 degrees to the vertical plane, and then we have taken the final front view and the final top view. So with that problem, I hope everything is clear to you guys. So if you guys want me to repeat, some of you guys asked me to repeat that class. So once all of these topics are over, I'm going to definitely repeat the topic. Actually, at that time I've lost the power too, so I was not able to utilize the time properly. There is nothing in my hand at that moment. Okay, so for today's class, we're going to talk about how to convert the given isometric view into an orthographic view. We haven't discussed in detail about the isometric view, but I told you what the basic principles and what is an isometric view actually is. So this one and this figure, these two are isometric views. So what we're going to do today is we will going to convert this isometric view into orthographic for these two problems. Okay, so first of all, let me recall some of the principles that I've told you in case of isometric views. So when do we use an isometric view actually? So an isometric view is used to represent all the dimensions. So whenever you want to convey the information to a person who is who is not an engineer or something, or who is not a technical person, or if you want to talk to a client, then you can use this isometric views. Other than that, if you want to go for the production and all, you have to use the orthographic views. Use mostly on orthographic views, 99%. And that too, here the dimensions might seems to be true, but they are actually having certain error. If you consider this 25 mm here as an example, this line won't be 25. Okay, this line dimension is not a true 25 mm line, because since there is certain inclination to this particular view, the dimensions are not true. Okay, so these dimensions are reduced by 81 point, these actual dimensions are 81.5% of this 25 mm. Okay, similarly 81.5% of 55 mm, these two lines are. Okay, so I will tell you, I will explain that in the next class, and why this 81.5% of the dimension has to be taken in the case of an isometric view. But for now, let me explain the orthographic projections of this particular isometric view. So what I'm going to do is, just like in the previous cases, I'm going to use the AutoCAD in order to, by the way, this is the syllabus which is related to the AutoCAD. This topic is from the 4th unit, at the end of the 4th unit. So here I'm going to make this figure in the 3 dimension in the AutoCAD, and after that I will explain about the orthographic views. Okay, and I think you guys might have, if you guys recall, I've told you about first angle projection and third angle projection as well. What is meant by first angle projection and what is meant by third angle projection, I explained that. So the first angle projection means that we have 4 different types of conventions, right? 4 quadrants, 4 different types of conventions. Among these 4 different types of variations, in which we only use particularly 2. If we treat the object is in the first quadrant, and then we take the projections, and that type of projections are known as first angle projections. And second type is the second one is the third angle projection. So third angle projection means object is assumed to be in the third quadrant, and then we take the orthographic projections, and that type of convention is actually a third angle projection. In this first angle projection, third angle projection, I don't think there is much of a variation, except that views positions will change. Okay, if the object is actually in the first quadrant, above the XY line there will be front view, and below the XY line there will be top view. And if if the object is actually in the third quadrant, then this top view will be above the XY line and the front view will be below the XY line. So that's the only difference. And we don't use the second angle projection and the fourth angle projection. We can't, because the views will overlap. If we use a second angle projection or a fourth angle projection, the views are going to overlap. We don't want, it is very difficult for us to understand if two different views are overlapped, right? So that's the reason why overlap means sorry, what am I actually saying? Say if this is the line which is related to the front view, and say this is the line which is actually related to the top view. Here two different lines are actually at the exact same position, so it is difficult for us to understand, it is difficult for us to read these two lines, right? Unless you observe it very keenly, you won't be able to understand that there are two different lines, right? So that's the reason why we don't use the second angle projection or fourth angle projection, but we use only the first angle projection and the third angle projection. I hope this is clear to you guys. I have recalled some of the points from the previous lectures. I'm going to start the AutoCAD. First I'm going to draw this one in the 3D view, and then I'm going to explain these orthographic views. So this dimension won't be enough. Okay. First let me draw this cubical portion at the bottom. Okay, I will draw a small a rectangle of dimension. I will draw the base face 55 by 50. Let's go to the top, it will be more convenient. This is 50, and again 55, 50. I think we need to rotate this one. Okay, now this one is 50 and this one is 55. Now what we are going to do is, I am going to join this one, join all of these four lines to make this as a single polyline. I am going to use the press pull command. What is the height of this one? This one is 10 mm, 10 mm dimension. 10, press enter. Now we have made the base. Since I need to draw some components above the surface, see here, of width we were not given, but it was given indirectly. Height is 25, length is 25, and we don't know the value of the width. So how to know the value of width? Here this dimension is 50 and this dimension is 25. So if you subtract 25 from the 50 dimension, if this line is 50, this line will also become 50, right? Right? So this dimension is 25 means this dimension is going to be also 25 mm. Orthogonal mode is on 25. I'm going to use the principal command again. This one has to be, raised to a dimension of 25. This one is a perfect cube. 25. Okay. Now there is one more region out there. Okay, which is this region. So how to extrude that one? See here, this dimension can be found from this dimension. This total dimension is 55. This total dimension is 55 means if this line is got extended, this total line will also becomes 55. Okay, I'm going to open this one in paint. Right. If this line, got extended like this, okay, so this dimension will also becomes 55, right? This dimension will also becomes 55 since this dimension is also 55. And now we know that this dimension is 25. This dimension is 25 and this dimension is 55. So which means if you subtract 25 from the 55, you will get this dimension, right? So which is nothing but 25 minus 55 means this will become 30. And we need some little more information. Yeah, see here, we know that this width here is 25, right? And if you subtract 5 from 25 means this dimension will become 20. Right? 20. This dimension is 30, 20, and the height is, see here, this particular base height is 10 and here it is 15, which means this one has a height of 5. So this one is 30, 20 and 5. Wait. Twenty, 30, 5. See here, that's the figure that was given to us, right? I've drawn this one completely in the AutoCAD. with the given dimensions. Now, if you are asked in the examination about these orthographic views, convert these isometric views into orthographic views, then what you can do is, just let me turn off the grid. Okay. We use first angle projection, right? So if the object is actually in the first quadrant means, then we will get the front view in the top, top view at the bottom, side view, okay, let me draw the front view. Actually, whenever you were given a figure like this, you will be mentioned a figure with an arrow indicating direction like this. Okay, so here also, so which means this direction actually indicates this is going to be the view that you're going to see in order to get the elevation of the front view. So what I'm going to do is I'm going to go to this front view. This is the front view right now. Okay, so whatever the lines or edges that you're going to see, you have to represent them in the thick lines, in the form of thick lines, and whatever the lines which are hidden from the view, they have to be given these dotted lines. I've told you about this Bureau of Indian Standard Conventions in the earlier class, so I hope you guys might have remembered this. So in the front view, I will see a dimension of 55. This dimension is 55, right? That is what was actually given. And now this height is 10. And this one is a perfect cube, so height 25 and width is also 25. This height is 25 and the width is also 25. That is what was actually given to us. Now, this one is having a height of 5 mm. I've explained this one already, since this one is 10 mm and this one is 15 mm, which means 5 mm actually belongs to this one. Okay, so 5 mm height and a width of 20 and 30. So this one is 30 mm line and this height is 5. Shrink this one a little bit. Okay, I don't want this thing to dominate. Okay. So now what I'm going to do is, similarly I'm going to take the other views as well. This one has to be a little down because I'm going to represent the dimensions as well. I don't want to mention it confused. You guys have learned the lettering, right? In that particular lettering only this front view, top view and side view has to be represented with 5 to 6 mm. That's up to you. Okay. Now the front view is got completed. Now I'm going to the top view. Actually, it has to be rotated this way. Yeah, in the top view, what you can actually see is very few faces here. These three faces again. So top view actually, these are projection lines. I thought I could never use, but these are actually needed. With the help of projection, the problem becomes very much easier. Now what I'm going to do is I should get this 55 by I0. Don't worry about it. Now there is a portion of, there is a square of 25 by 25. So we can directly take this dimension 25. This one is not, yeah, right. 25 again. Now there is a portion of dimension at 20. I'm gonna use different colors so that you guys can understand. At the top view we are usually giving red color. I think we need a no. That's the front view and that's the top view. See here, observe this top view and this one here. Both are same, right? Ortho means, you know, the rays are at 90 degrees to this to the surface. So, but whereas our eyes can see the rays are getting diverging. Okay, there is a diverging, there is a diversion. But whereas ortho views means we have to take the rays at 90 degrees. So ortho in Greek code means 90. Okay, now, so that's the front view and that's the top view. And now we're about to draw the side view. You have two different sides, right? Which side you have to choose? If you guys got a confusion for that one, I'm gonna explain this. And here is a first angle projection symbol. You guys might have seen this symbol in the drawing sheets that you have bought. Okay, you guys might have seen this symbol in the drawing sheets at the bottom right side corner in the title box, below the in the bottom left corner of the title box. So what is this symbol and what does it actually represent? So the first angle projection, whenever you're trying to take, when the object is in the first quadrant, first you will take this view and then you will take this view. Okay, and of course the top view has to come below. The top view has not represented, but this hand. If it is a third angle projection, this shape will come here and this one is going to come here. So that's the difference between these two during this first angle projection. So first, since this is the front view that we have chosen, which is like this tabloid object, and after that, so the side view will become this one. Sometimes he might ask you for give us the right side view or something like that, but I'm not saying that these three views are just enough to talk about a particular geometry, but mostly these three views are enough. But if there is some complicated geometry is there, then you must choose more than three views, sometimes sectional views also. Okay, I'll talk about the sectional views later, but understand right now this is the side view that we needed. So in this side view, what are the things we are seeing? I assume okay. Now let's come to the figure ones. What is the height of this particular square area? 25, right? What is the width? 25, right? If you observe closely, this portion is still there, right? And this edge is also still there. But can you guys actually able to see those two edges? Can you guys see those two edges? No, right? Since they do exist and they are not visible in this particular view, then you have to represent them with the dotted lines. You might ask me, sir, why can't we use the edges which are, this edge is also not visible, this edge is also not visible, this edge is also not visible. So then why we are talking about that particular edge only? Those two edges only. See here. So when you're trying to watch this particular edge here, these two edges seems to be on the same straight line, right? Then a single dotted line is enough, since these two edges are non-visible. Clear? And similarly, these two edges are getting overlapped. So that's why we don't need to use two different dotted lines. We have to use only single dotted line. That's enough for you. That's enough for us. So what I'm going to do is I'm gonna finish this one first. I don't think this is 25. 25. Okay. These are all visible at just yes. Now I'm going to give a blue color to this one since this is a side view. I'm going to trim all the extended portions here so that I can neatly outline this figure. So this is the one that we are actually talking about, so let me trim this one also. I'm going to create a new layer. Out. Hidden lines, the properties of this particular layer would be I'm going to select this one, give this one a blue color, and then I'm going to add this to hidden layers. I'm going to decrease the LTA scaling to 0.05. See here, can you guys see these dotted lines? These dotted lines are actually representing this particular edge. We are talking about this edge, through this dotted line. Now, and that too, we can't even talk about this particular edge here. Sorry, we have to talk about this particular edge here also. So this thing won't last for up to this two dimensions. This one has to be having should be fine. 15 would be enough. Yeah. I'm gonna add this to this one. I'm going to change the color to blue. Now see here, this is how we represent these two edges, or whatever the edges are there which are hidden, we have to represent them. Okay, since from this view we won't be able to see these two edges, right? So that's the reason why we have to represent them with these dotted lines. I hope it is clear to you guys. If you still have a problem, you can just replay it, no problem. No, otherwise, if your doubt is still not clarified, you can contact me. I'm going to mark all the dimensions. That's the front view. Top view. Okay. Now remember, if you guys remember, we have some dimensioning principles too. You should follow those principles strictly. if I okay, we have given all the dimensions. So these are the orthographic views of the given figure. Okay, I hope it is clear to you guys. I'm moving to the next problem. I'm going to attach these files in the classroom. You can use them if you want to. It is first my okay. Okay, so our next problem is this one. This one is better. Okay, I'm going to draw this one quickly in the AutoCAD. So 75 by 50. First thing is first, join all of them. Use the press pull command up to dimension of 12. That is what. I'm going to draw this one. This one is this dimension 75 55, 55 height 25. That snap is not working. Oh, darn it. I'm gonna join this. I can erase this. Actually, I don't need these things, but whereas I want to be precise. Okay. No, let's take the plus. Children height. And even if the object snap is not turned on, both are not snapped. Okay, this is the figure that was actually given to us, right? So here we were given an arrow direction. So this is going to be the elevation. So if I watch this one from the front, so these are the edges that I actually see. Now I'm gonna take a new one. I'm gonna draw the box later. I don't want to waste time. 75. Height of 12. 25. No. 25. 25. And 22. This is 25. This dimension is 20. And we need a point at a distance of 20. So you see here. So when you watch this one from the front view, this face we will going to see 75 dimension, and all of these lines seems to be at the same location. Okay, and this is the solid object. So 25 mm height and 20 mm width, and these two wedges are getting points are getting connected by this wedge shape. This dimension here is actually 20. Okay, the distance from this location to this location is actually 20. So I'm going to use that. Yeah, I've already made that. So I'm going to connect these 2 points. So that's the figure that I'm actually seeing from the front, right? So that's the front view. Okay, let me give green color to this one. Okay, since that's the front view, let me give the dimensions as well. Okay, I'm gonna finish this one. Yeah, 37. 12 plus 25 is 37. Correct. That's fine with this one. Now let's go to the top view. For the top view, I'm going to take the projections. Okay. I'm going to use this one to draw the top view, and then I'm going to show this to you in the 3D view. Okay, in the top view, I'm going to see this face completely. So, 75. Now, this horizontal dimension is 50. Now again 75. So at a distance of 20 to a dimension of 25. And there is one more thing, distance 25, 12, 25, 12 again. Okay, that is what we actually see, and there is one more. This edge I have to draw that one as well at a dimension of, see here, I can directly take the projection as well. Okay, I don't want to trim this, but I will give a different line. All the geometries are connected. अरे यार, no. So we'll give the dimensions to the objects as well. See here, from these projections also you can get these values, get these locations. See here, even though the views are different, they are somehow connected, right? Okay, so let me give the dimensions now. gonna delete all of them because but if you want to use the projectors, you can use them that way. Are there any dimensions that are changed here? Now let's take the projections to the left. And when you watch this one from the side view, which means this view, since this is the front view, this is going to be the side view. So whatever the objects that we are or faces that we are going to see from this view has to be, represented, not this way. Did we forget any hidden edges here? No. In this view there are no hidden edges. In this view also there are no hidden edges. Okay. So when you watch it this one from this view, 50 by 12, see here. This is a hidden edge. I'll show you. 50 by 12. This face will look like a simple rectangle of 25 height and a width of 25. Now we need to talk about this edge. I'm going to connect all of them for a moment. This one has to be added to the... Okay, I haven't created layer in this particular drawing right. Okay, now this is a hidden edge. This particular edges, similarly there is another edge similar to this one at this location also, but we don't able to see these two edges, so we have to represent them like this. So none of the edges are overlapping, none of the edges are overlapping with these, these two edges, so that's the reason why we have to represent them. Okay, and now let me draw the projections again. Okay, that is what we see. Let me give the dimensions. Um, and view top view and side view. So this is all first angle projection, right? If it is a third angle projection, it is going to be, I'm going to have to trim these portions. Actually, this box is not sufficient to this one. This line is not in, let me select. Yeah. So here, if it is a third angle projection, top view will be there on the top, and we will take different side. Okay. So top view will be here, front view will be here, and side view will be here. If it is a first angle projection, front view will be here, top view will be here, and side view will be here. I'm gonna mark these dimensions as well so that it will be clear for you guys. Not the dimension, these projections. This one is first angle projection, and this one is third angle projection. If we were to talk about the second and fourth angle also, I will discuss about only third angle projection, second angle projection, then you will come to know what is the fourth angle projection. If it is the second angle projection, I'm going to copy this one entirely. I cut that one. If it is a second angle projection, then this top view and front view will be like this. Are you guys able to find the difference between front view and top view right now? Since there is some color coding, you guys are able to understand at somewhat. So if it is a second angle projection, it will look like this. Front view will be there below the top view. So that's why we don't use the second angle projection. We use only the first angle projection and the third angle projection. Okay? And similarly, if it is a fourth angle projection, both of them will come at the bottom of the X-Y. No. They overlap, right? So we don't use them. So that's the reason why we use only first angle projection or third angle projection. I hope it is clear to you guys. In the next class, we will discuss about the isometric view principles. Okay? I'll see you guys in the next class.
In this video we will discuss first angle method of projection. Object is placed in first quadrant, that is in front of VP and above HP. The object lies between observer and plane of projection. In first angle projection, the top view is below the front view. Each projection shows the view of that surface of the object, which is nearest to the observer. It is absolutely essential to indicate the method of projection used for every drawing. The symbol used for first angle projection is as shown in figure. The symbol used for first angle projection is actually a projections of a frustum of cone of convenient dimensions according to the size of drawing. Front view and left-hand side view of frustum are drawn in symbol. In order to describe maximum features of the object, sometimes two views of the orthographic projection are not sufficient. We have to draw side views in addition to front view and top view of the object. Front view will be drawn in the direction of arrow given. After projecting the object on planes of projection, we get front view in VP, top view in HP, left-hand side view in right side POP and right-hand side view in left side POP. Four views of the object by first angle method of projection are shown in figure. Front view is drawn in the direction of arrow. Top view is below the front view. LHSV is to the right of front view and RHSV is to the left of front view.
Hello, today I will take you through theory of projections. The projection is the process of creating an image of the object on the paper as it appears when observed in a particular direction. The shape of an object is represented as a combination of elements, points, lines, and planes. Using these elements as tools of drawing, we can project an outline of the object on the paper. We will use orthographic projection, where lines of sight are parallel to each other. These lines emerge from the corner points of the object and strike the projection plane. The image formed on the projection plane is known as the projection. The lines of sight are also known as the projectors. The size and the shape of the projection depends on the angle at which the object is being viewed and the distance between the object and the viewer. The projectors are perpendicular to the plane of projection. This type is known as orthogonal projection, which is prominently used in engineering drawing as they show true size proportions and shape of the objects. Planes of projection are mutually perpendicular planes known as principal or reference planes. One of them is the vertical plane VP and other one is horizontal plane HP. The intersecting line XY is the reference line. These intersecting planes create four quadrants named as first, second, third and fourth in anti-clockwise direction. There is one more plane known as auxiliary vertical plane AVP or profile plane PP. We use AVP when the view is from the left side or the right side of the object. Alright, now consider the object in the first quadrant. Looking at it from the front side, the image is formed on the VP and is known as front view or elevation. And if we look at it from the top, then the image formed on the HP is known as top view or plan. As the object is in the first quadrant, the projection obtained is the first angle projection. Similarly, if object is situated in the third quadrant, then projection is known as third angle projection. In the first angle projection, the object lies above HP and in front of VP. The projection of the object is like a mirror image. For the third angle projection, the object lies below the HP and behind VP, and plane of projection is assumed to be transparent, lies between the observer and the object. So the line of sight passes through the plane, thus forming an image of the object. So with these fundamentals of projection, we are ready to delve deeper into engineering drawing.
I'm gonna add 3 to 4 figures in your in the Google Classroom. So I suggest all of you to draw these figures in your drawing sheets if it is possible, or otherwise you can also draw them in your drawing observation. And if you guys have any doubts, you can ask me in the Google Classroom and I will be very much happy to answer all of your questions. And lastly, and this is the end of the 4th unit, and we will going to enter into the 5th unit, since most of the portions that was actually covered regarding these isometric views. Until now we have seen conversion of isometric to orthographic views, but whereas in the 5th unit you will going to see that we will be given the orthographic views. Using these orthographic views, we have to convert these orthographic views into the isometric views. I'll try to complete it as much as early as possible, because by tomorrow I have to finish all the 5 units. But whereas I'll go slow, if there is a possibility for me, I will take one more class too. So during this 5th unit, I'm going to cover a lot of principles which are actually related to these isometric views, and I will explain to you guys what is an isometric line, isometric axis. So likewise, we're going to discuss a lot regarding the 5th unit. Okay, hope you guys have learned something today, and if you guys have any doubts, you can post them right now in the Google Classroom.